Today, let's discuss the inverse of a 3 by 3 matrix. It's very easy. First of all, we have done the inverse of a 2 by 2 matrix. Check in this channel for that particular video. Now, for inverse of a 3 by 3 matrix, we know that if you are asked to find the inverse of a matrix, that the formula is A inverse is what? The adjoint of A divided by the determinant of A. Adjoint of A divided by the determinant of A. All right, let's start first of all with what? Determinant of this A. This is a 3 by 3 matrix. To find the determinant of a 3 by 3 matrix, we need to find the cofactors of the first row. Okay, just look out and see how I'm going to do it. Now we know, like I said, if you don't understand what I'm saying, check this video that I just referred you to so that you understand better. You are going to have plus, minus, plus. I also explained why these signs are there, okay, or how we obtain these signs in that video. Now we have plus, minus, plus. So to get the determinant of this particular matrix now, the first number here is going to be plus 5 because there is plus what on top of the 5. So it's going to be plus 5. Then we are going to open what? A determinant line for a determinant bracket for what? A 2 by 2 matrix we are going to form here. Now, how do we form this 2 by 2 matrix? We are going to cover anything concerning 5. We are going to cover this place and this place. By the time you cover this line and this line that is concerning this 5, you are going to have 4, 2, and 7, 6 visible. And that is what you are going to write 4, 2, 7, 6. This is the matrix that you have formed, the 2 by 2 matrix. Okay, you are going to have minus 2, minus 2. You also open what? Your determinant bracket. When you look at this now, you are going to have, when you cover these two, this line that contains 2 vertically and the line that also contains 2 horizontally, like this, like this. You notice that you have 3, 2, and 1, 6 remaining. Okay, so you are going to have 3, 2, 1, 6 remaining. Now we have plus 1. You write your plus 1 and you also open your what? Your determinant bracket. So when you close everything concerning 1, both vertically and horizontally, if I place my hand, if I should cover this line like this and also cover this line like this that is containing 1, you are going to have 3, 4, 1, 7 visible. 3, 4, 1, 7 after covering here and here because we are talking of 1. 3, 4, 1, 7. So you're going to have 3, 4, 1, 7. Very easy, right? Okay, if this is the first time you're coming across this channel, please, I think this is the right time for you to click that subscription button. Subscribe to the channel so that you don't miss my videos, okay? And also remember to on your notification bell. Then help me to comment, like, and share. It's very important so that this video will be distributed to those students that need it for their exams. Thank you very much. Now we go ahead and solve the determinant of A. It's going to be 5. Now, for you to get the determinant of this 2 by 2 matrix that we have here, okay, I've also explained how to find the determinant of a 2 by 2 matrix. Check it also in this channel. So we are going to concentrate on the leading diagonal. This forms our leading diagonal, this 4 and 6. So we are going to do 4 times 6, 4 times 6, which will give us 24, minus 2 times 7, which will give us 14. Okay, 4 times 6 will give us 24. 7 times 2 will give us 14. You subtract. Okay, minus 2. We also open our bracket. This is our leading diagonal. 3 times 6 will give us 18. Minus 1 times 2 will give us 2. Plus, we have 1. We also open our bracket. So you are going to have 3 times 7, which is 21, minus 1 times 4, which is 4. Very easy. So we go ahead and solve this. So this is going to be 5 into 24 minus 14 will give us 10, right? Minus 2 bracket 18 minus 2 will give us 16. Plus 1 bracket 21 minus 4 will give us 17. All right, our A determinant then is going to be 5 times 10 will give us 50. Minus 2 times 16 will give us 32. Plus 1 times 17 will give us 17. When we solve this, our A determinant will be equal to 35. Okay, because 50 minus 32 will give us 18, and 18 plus 17 is going to give us 35. So our determinant of A is this 35. We have found this. Now for us to get this A inverse, we need adjoint of A. Okay, for adjoint of a 2 by 2 matrix, check this channel as well for that. Okay, I have a video, a detailed video on that. Now for adjoint of a 3 by 3 matrix is a different ball game. Okay, so let's go ahead and find the adjoint of A. First of all, we need to get the cofactors of all these numbers here. We are going to do it one by one. So I want you to go and drink a chill pill, relax, bring your popcorn. But while chewing, ensure that you also concentrate on what I'm doing, okay? Because it's going to take us a bit of time. All right, so we are going to find the cofactors of this A, okay? Let's go over and find cofactors of what? The first row. This is the first row of this matrix of what? Row 1. Let's call it row 1. So we are going to start with cofactor of 5. Cofactor of 5. Now, how do we do it? It's going to be equal to, you know that there is a plus sign here. So just put that plus sign and open just the same way we formed this particular matrix here. We are going to use the same way to get the cofactor, except that we are not going to multiply it by 5. Okay, so we are going to write the sign and we are going to open our determinant bracket. So when you cover this like this and also cover it horizontally, cover this line containing 5. Remember that we are talking about 5. Okay, don't worry, stick with me. It's very easy. You are going to love it at the end. See, when you cover this line that is containing this 5 vertically and horizontally, you just like covering this with this. Let me bring my duster and covering here. You notice 4 to 7 6. 4 to 7 6 will be what? Will be visible. So that is what you write here. 4 2 7 6. Okay, so this is what we are going to have. And when you solve this, remember the way we solved it here. You are going to concentrate on the leading diagonal, which is what? 4 and what? 6. So 4 times 6 will give us what? Remember you have plus outside. 4 times 6 will give us 24. Minus 2 times 7 will give us 14. So you notice that this is equal to 10. So it means that the cofactor of 5 is 10. Very easy. So we are going to keep this. We are going over to get the cofactor of 2, cofactor of 1, 3, 4, 2, 4, 7, and 6. Everything before we get our adjoint. Like I said, take a chill pill and follow me through. Do not quit. Okay, the result is very close. All right, the next thing we need to get is the cofactor of 2. We have gotten the cofactor of 5. We get the cofactor of 2. Now remember that there is negative on top of these two, so it's going to be minus. Let's write cofactor of 2. Cofactor of 2. So it's going to be equal to minus, all right, minus, you put your brackets. So when you cover this place and this place, that is vertically and horizontally, you are going to have 3 2 1 6 remaining. Vertically, this line will be crossed. Horizontally, this line will be crossed. Okay, you have 3 2 1 6. So we have 3 2 1 6. So we go ahead and solve this. Okay, 3 2 1 6. We go ahead and solve this. So this is going to be minus. We open our bracket. 3 times 6 will give us 18. Minus 2 times 1 will give us 2. So we are going to have minus 16. That is 18 minus 2 will give us 16. But remember there is a negative sign here. Okay, so that is how we got minus 16. Okay, that means the cofactor of 2 is minus 16. Let's go ahead and get that of 1. Now cofactor of 1 is going to be equal to, now 1 has a positive sign. Okay, so we put that positive, we open our bracket. So when we cover 1 vertically and horizontally, we are going to have 3 4 1 7. 3 4 1 7. We go ahead and solve this as well. So this is it. 3 times 7 will give us 21. Minus 1 times 4 will give us 4. So we are going to have 17. It's going to be 17 because this is positive. so it's going to be 17. Okay, we are done with cofactor of our first row. We have done for 5, 2 and 1. We go over to the second row. Now, because this is plus minus plus, because this one is plus, this is going to be minus. The sign that will be on top of this 3 will be minus, this will be plus, this will be minus. Okay, so minus plus minus, like I said, if you are like how, where are those signs coming from? Check my video on adjoint of a matrix. I explained it there. Okay, so we are going to start what? Finding the cofactors of the second row. So let's do that. Cofactors of what? The second row. Okay, let's go ahead and do that. Well, I will keep managing my board. I'll keep managing my board. So our A determinant is 35. So I'm going to clean this place now. Our A determinant is what? 35. So I'll write it somewhere and then I'll wipe this place. Okay. So cofactors of the second row. Now the second row we start with minus 3, right? There is minus there. So for 3, the cofactor of 3. Cofactor of 3 is going to be equal to, there is negative there, so you bring your negative, open your determinant bracket. Now we are going to have, when you cover here and here, that is vertically, anything that concerns 3, if you cross it vertically and cross it horizontally, you notice that you're going to have 2176. 2176. Then we go ahead and solve this. Okay, 2176, we go ahead and solve it. So it's going to be minus, we open our bracket, 2 times 6 will give us 12, minus 1 times 7 will give us 7. And when you solve this, you are going to have 12 minus 7, 5. But remember that there is negative sign outside the bracket, so it's going to be minus 5. Now let's go over and get cofactor of 4. Okay, cofactor of 4 is going to be equal to, we have plus, so you write your plus and you open your determinant bracket as well. So we are going to cover 4 vertically and we are going to cover it horizontally. Vertically, horizontally, you are going to have 5116, 5116, 5116. Now when you solve this, you are going to have 5 times 6 is going to be 30, minus 1 times 1 will give you 1, which will give you 29. I wasn't interested in this sign because it's positive, so I know that whatever I get here will not be affected. It's positive. Okay, let's find cofactor of 2. Cofactor of what? 2 is going to be equal to, you know, this particular 2, if we cover it vertically like this and horizontally like this line and this line we go, we have 5, 2 and 1, 7. So it's going to be, remember there is negative there, minus 5, 2, 1, 7. We go ahead and do what? And solve. Because of this negative, I will be careful because I know it's going to affect my results later. So 5 times 7 will give us 35. Minus 1 times 2 will give us 2. So this will give us 35 minus 2 will give us 33, right? Remember our negative sign, so it's going to be minus 33. Like this, we have found the cofactors of what? The second row. Now we go ahead and find the cofactors of the third row. Pardon me, please. These are what we got because I need to take note of that somewhere so that I can wipe this board so that it will accommodate what I'm doing. Now the cofactor we got for our first row is 10, minus 16 and 17. So I'll write it somewhere. 10, minus 15 and 17. Okay, I've taken note of that. All right, I've taken note of that. So I'm going to wipe the board now. So let's go ahead and find cofactors of the third row. Cofactors of the third row. Now we have 176 as our third row. So what do? I'll first of all get cofactor of the first number in the third row, which is 1. Cofactor of 1 is equal to, first of all, I need the sign that will be here. My last sign here is negative. That means I'm going to have plus here, minus and plus. Okay, so that means plus 1, plus 1. We open our determinant sign. Stick with me. Hope you are with your popcorn, like I said. Hope you are with your popcorn. Okay. All right. Now this is plus 1. So we are going to cover everything concerning 1 vertically and horizontally. And when we do that, we are going to have 2, 1, 4, 2 remaining. 2, 1, 4, 2. Now this is equal to plus 1 bracket. 2 times 2 will give us what? 4 minus 4. So it's going to be 1 times 0, which will give us 0. So the cofactor of 1 is what? 0. You go ahead and get cofactor of the other element following 1, which is 7. Is 7 and is equal to, there is negative on top of it. So write your negative and draw your determinant sign. Okay, hope all these are understandable. So when we cover this 7 vertically and horizontally, this line will go. So you're left with 5, 1, 3, 2. 5, 1, 3, 2. Now if we solve this, we have minus, this minus 5 times 2 will give us 10 minus 3. So it's going to be 10 minus 3 will give us 7. But remember that we have negative sign here, so it's going to be minus 7. Okay, the last but not the least then is what? The cofactor of this 6 remaining. So cofactor of 6, cofactor of 6 is going to be equal to, remember that this 6 is positive, you can see that, so it's going to be plus. We open our determinant line. So when we cover this vertically and horizontally, we are going to have 5, 2, 3, 4. 5, 2, 3, 4. Now 5 times 4 will give us 20, right? So we are going to have 20 minus 3 times 2 will give us 6, and 20 minus 6 is 14. So it means that the cofactor of 6 is what? 14. Now it is time for us to form what? A matrix of all these cofactors. See what I mean? Matrix of this cofactor is going to be, so the matrix of the cofactors will be what? So the cofactors of our first row is what? 10, then this minus 16, and this what? 17. So we are going to write it 10 minus 16 and 17. That is for the first row. Now for the second row, cofactors of the second row, we have minus 5, 29 and minus 33. Minus 5, 29 and minus 33. Now for the third row, we have 0, minus 7 and 14. 0, minus 7 and 14. Okay, at this point, we don't need all this again. So I'm going to wipe my board clean and neat so that we can continue. Now that we have gotten this, we are going to get the transpose of this matrix. Let's get the transpose. The transpose now is going to be equal to what? What is transpose? When you want to transpose a matrix, the only thing you need to do there is you need to make your row to become your column. So this first row now becomes my first column, the second row becomes my second column, the third row becomes my third column. See what I'm going to do? 10 minus 16, 17. Instead of me to write it horizontally, I will now write it vertically. 10 minus 16, 17. Then minus 5, 29 minus 33, I will write it vertically. Minus 5, 29 minus 33. Then the same thing with the last line. 0, minus 7 and 14. And this is the transpose of this matrix. And this transpose that we have gotten is our is our adjoint. This is the adjoint of A. So remember that we are looking for what? A inverse. And our A inverse is equal to adjoint over what? The determinant. Now we have found our adjoint, which is what? This. So we have 10 minus 5, 0, minus 16, 29 minus 7. 17 minus 33, 14. Divided by our A, determinant of A. Remember that determinant of A, we got 35, right? Over 35. Now, what are we going to do? We are going to divide each element here by this 35. Each of them, we are going to divide it by 35. So let's go. We are going to have that A inverse is going to be equal to 10 divided by 35, right? Then minus 5 divided by 35. 0 divided by 35 minus 16 divided by 35. 29 divided by 35 minus 7 divided by 35. Okay, 17 divided by 35 minus 33 divided by 35 and 14 divided by 35. So we are going to get this matrix now. Let's go ahead and do that. When we reduce this to its lowest term, notice that 5 can divide 10 to give you what? 2 over. 5 can divide 35 to give you what? 7. The same thing here. 5 can divide minus 5 to give you what? Minus 1. Divide 35 to give you what? 7. Now 0 divided by 35 is 0. For this one, they don't have common factor, so we have minus 16 over 35. This one is same thing as 29 over 35. Then for this, 7 will divide itself to give you minus 1. That is 7 divide minus 7 will give you minus 1. If you divide 35, you are going to have 5. Alright, we go over to the third line. When this one is still 17 over 35 in its lowest term. Now this one is still 33 over 35 minus 33 over 35. And then for this last part, okay, when 7 divides 14, you are going to have 2 over. When it divides 35, you are going to have 5. And this becomes our A inverse. Thank you so much for watching and do have a lovely day. Bye.